Hey there, welcome back once again, guys. In this video we're going to be taking a look at the exponential function. Okay, so let's punch in the standard form for any exponential function, and so that's going to be fx is equal to a times b to the power of x, and we'll add both sliders. So what you see right now is an orange straight line. This is not yet an exponential function because a and b's value is both 1. Okay, now let's first have a look at what a's value does. So a's value is sort of like the initial point on the exponential function, or like the starting point, right? So it depends, are we going to start our function at 1, or we're going to start it at any number greater than that. And so you can see as I increase or decrease a's value, the function would raise its level. Okay, but we're going to be starting at 1, so I'll just leave a's value at 1. Now let's focus more of our attention to b. Notice what happens as we increase b's value. So now this function is starting to take on the form of an exponential function. Okay, so notice as we increase b's value, this graph also steepens like that. Okay, so this graph starts off very shallow but then gets steeper towards the end. The more we increase b's value, the more steeper the graph gets. But notice when b's value gets closer to 1, the graph tends to flatten out and become again a straight line. So what happens when b's value becomes less than 1? Let's have a look. So if we go to a value like 0.9, notice how the graph tends to sort of decrease now and steepen rather in the opposite direction. So this is a graph that has a negative slope, right? The gradient of this graph is decreasing because b's value is now less than 1. Okay, notice as it goes closer and closer to 0, you can see how this graph, the gradient is becoming steeper and steeper, but in the negative direction. Okay, it's going down, it's decreasing. This is called a decaying exponential function, whereas the previous one we had earlier, this was a growth exponential function. Now, similar to what we did with the straight line function, here I'm going to add some transformations to a second function, one that is similar to our original function, and we'll have a look at the changes that happens. Right, so this blue function you see over here is actually just a copy of the orange one we had earlier. As you can see, it's the exact same, but now I'm going to add some value k, and you can already see what happens. K's value is 1, and notice now how this blue graph actually moved 1 unit higher. Remember, k, all k does, it's a constant, so when you add a constant, it moves something up by that constant. So if it's 1, it would move the graph 1 unit up. If it's anything greater than that, it moves it that amount of units up. Okay, I'm going to place k by 7. Let's try and get it there by 7. Okay, notice that the y-intercept of our original function is 0 and 1. That's the coordinates for our y-intercept. But when we have a look at our intercept for the translated function, that is 0 and 8. Okay, so we can see it moved exactly 7 units upwards. From 1 to 8 is 7 units. And that's what happens when you add some value k, if k is 7 units. Okay, now this k doesn't only have to be added to the entire function, the a, b to the power of x, but it will also be added to the x component. So let's have a look at what happens when you add some variable to the x component. And this time I'll just choose a different letter. So let's go with p. Okay, so right now both k and p is 0. Okay, so the fx graph is right on top of the gx graph, or vice versa. Okay, they essentially the same graph at this point. But now as I increase p's value, notice that this blue graph is going to shift to the left. As I increase p's value, the blue graph goes to the left, and as I decrease p's value, the blue graph goes to the right of our original function. Notice the orange one is the original. As we increase or decrease p's value, it goes to the right, and as we increase P's value, it goes to the left. So kind of strange, very counterintuitive. You would think that right is positive and left is negative, but it's the exact opposite over here. We increasing P's value, it's going to the left, and when we decrease P's value, the graph moves to the right. Okay, this is what we call translations. Right, now let's move on to reflections. And what we're going to do is play around with this gx function. We're going to reflect it about either the x-axis or the y-axis. Let's start with reflecting it about the x-axis. Okay, so this one is interesting. If you want to reflect it about the x-axis, simply slap a negative to the entire function, like multiply the whole function by a negative. So we're going to do that over here. In front of AB, I'm just going to put a negative. Okay, can you now see how this function is being reflected? Okay, compare this orange function to the now reflected blue function. And hope you can see that reflection happening in the x-axis. Okay, I'm going to get rid of the negative over there. And now instead of applying it to the entire function, let's only apply the negative to the x value. And now I want you to see what reflection do you see now? Can you see it's still a reflection, but instead of the orange graph being reflected in the x-axis, it's now being reflected in the y-axis. So there you go. Okay, hope you managed to increase your knowledge. Don't just keep this for yourself, share this with your friends, and I'll see you in the next video.